a few minutes, we'd like you to imagine you're here at Crotonville at the Management Research and Development Institute. You'll be seeing and hearing on film several presentations which report on the early success of 3 new approaches to cost reduction, approaches which are working effectively now in many General Electric product departments. We're taking your time because we think it's important that you hear these messages and that you know about the new techniques they discuss. These are approaches which can be applied in your business, and they may make a significant contribution to profitability. The first new approach is called value control. It is a method of attacking direct costs. On this subject, you will hear a presentation by H.B. Miller with case histories demonstrating how effective this new method has already proved to be. The second new approach is a method of attacking indirect costs. And you will hear a presentation by J.P. Thibodeau and C.B. Fontaine. This presentation also includes specific case histories to demonstrate effectiveness of the method. And finally, the third approach attacks both direct and indirect costs. You will hear a discussion by F.K. McCune, again with case histories to show how this new approach is being applied successfully. For some of you, these subjects will be brand new. For others, what you will be hearing is a progress report on a growing number of successful applications of these new techniques and disciplines. For all of us, the 3 new approaches to cost reduction represent an exciting opportunity. Let's begin with value control and Mr. H.B. Miller. Al?
Thank you. My purpose today is to demonstrate our belief that value control is now ready for general use within the company. The basic concept of value control is to think of a product as a hierarchy of functions rather than an assembly of hardware. Take one of Louisville's room air conditioners, for example. The value control method begins by describing the conditioner's functions in a systematic way. To begin with, it conditions air. This is the first order function. We can subdivide the basic product function into 4 parts. Second order functions which make possible the conditioning of air. We've begun building what we call a function structure, and although it seems deceptively simple, it is difficult to build one. This is a further subdivision into third order functions, 10 of them. If you went one step further, you'd find a final subdivision into 33 different fourth order functions. We haven't room for all of them. But to illustrate, let's take the subfunction called support system and follow it through by itself. You get a structure that looks like this. A listing of the complete fourth order functional requirements necessary to support the system. In this structure of functions, there is no reference to hardware. Yet this is, in fact, a concise statement of the design and subsequent manufacturing problem. The beauty of it is that dealing in functions rather than in parts helps us to clean our minds and the minds of our marketing, engineering, and manufacturing men of preconceived notions and prejudices about hardware. Now let's see how the completed function structure is made useful. First, present prime costs can be allocated for each individual function. In other words, you assign the total cost of materials and direct labor, divided as it applies to the performance of each function. The prime cost of housing components is $9.27. The cost invested in facilitating installation is $7.16 of direct labor and materials. Now, for the first time, we know what the functions of our product really cost. We also have a universal means of comparing our product and our competition's, unencumbered by problems of hardware. Logically enough, we call the procedure competitive analysis. In the case of the Louisville room air conditioner, comparable models of 6 other makes were analyzed and compared. To keep it simple, let's look at just the 2 lowest cost competitors, Amana and Gibson. Using the same function structure, we costed their products by function. And here's the kind of comparison we get for the subfunctions we broke out earlier. The $6.03 which Amana invests in direct labor and materials to accomplish the function of housing components, is the lowest of all 6 competitors analyzed, and it is only 2/3 of the General Electric cost. Gibson's $2.22 to facilitate installation is the lowest for that function and is 1/3 lower than the General Electric cost. If we showed the whole structure, all the functions and all 6 competitors, you would see that each company, including General Electric, produces some functions at lower cost than anyone else. But even more important, we can set up an important benchmark for ourselves, what we call the minimum competitive composite. This is a listing of the lowest cost way that any competitor has discovered for accomplishing each individual function, so long as function performance meets market requirements. Actual prime cost figures, simplified so that only second-order functions are shown and totaled, look like this. Bear in mind that the complete function structure breaks these dollar figures down twice more into 10 third-order functions and finally into 33 fourth-order functions. The totals show Gibson, the lowest cost competitor, at $76.85, lower than GE 78.31, and Amana's still higher, $79.93. Incidentally, the prime costs of the 4 competitors not listed range from $80 to $85, yet they perform some of the second-order functions at low cost. For example, one of the 4 competitors processes air for $44.75, which gives us that figure for the composite column. The lowest of all costs to support the system is $8.25. One competitor performs the functions of enhancing market value for $5.29, and product assembly is constant at $6.41. So the minimum competitive composite adds up to $64.70, about $12 less than Gibson's $76.85, which is the best competitive figure. And so we've learned that if we can perform the air processing function as economically as one competitor, support the system as economically as another, and so forth, we can get nearly $14 a unit out of our prime costs. Challenging as this competitive composite is as a goal, it's not the end of the road. There's one more step we can take, one further goal to establish. That's the value standard, a name we've given to the listing of costs which represent the lowest values that modern technology can achieve in providing these functions to acceptable standards. They represent the most economical way known to perform the function, and the total for this product is only $54.52, 30% lower than our present General Electric cost of $78.31. Now we know that this value standard can be achieved physically, but the judgment must always be made as to how far to go down this road. The room air conditioner people are currently reviewing their product by this functional value approach to establish a detailed program. They must determine what steps to take and when. They must also integrate this work with their other models. While it's dangerous to forecast, our experience with the other departments indicates that they will probably be able to define and achieve a program leading to about a 20% reduction in their present prime costs. These cost improvements can be achieved without degrading market acceptability of the product. In fact, to assure this, performance values are compared in much the same way as costs. A minimum competitive composite is drawn up and a performance value standard established. In other words, we make sure that the lower cost product meets customer needs and desires. Briefly, that's how the method works. The really important questions are, will it work for you? Is it worth the effort? And will it lead to real cost savings? Gentlemen, the answers are positive, and they are exciting. Case histories make the points best. Let's begin with this competitive analysis developed by the Canadian General Electric Company. The product is their 300 kilowatt, 1800 RPM diesel-driven generator. Canadian GE identified real room for improvement. Their prime cost of $3,599 compares with competitive figures of $2,877 and $2,529, and with a minimum competitive composite of $2,332. The value standard is way down at $1,250. If you feel incredulous and doubt the validity of this standard, I can tell you that preliminary designs to achieve this cost have been produced in Peterborough. Judgments based on the investment required have led to a decision to implement the study at a $1,625 level, which requires a $50,000 tool cost. Prototypes have been built and tested. Production designs are underway. Here's a completely different product, the standard upright vacuum cleaner. The minimum competitive composite of $11.04 is well below GE's $15.03, and the value standard is still much lower, $8.07. I understand they have now established a $9 prime cost level for their new design. There are more studies we could show you, but they only confirm the power of this method for identifying cost reduction potential. So let's look at results. What was really achieved as study information was turned into action? Industry control was the first experimental operation in the new kind of work, followed shortly by hot point kitchen appliances. Both these efforts were successful, despite the crudeness of the measurement tools then available. Industry control established value standard reduction goals of 15 to 65%, and actually achieved reductions of 10 to 60%, a remarkable performance. The range of numbers means that more than one product line is involved. Hot point kitchen appliances did every bit as well against its standards. The point to remember is that these value standard figures represent ultimate stretch goals. They are greater reductions than even the minimum competitive composite figures. The switchgear team has been operating successfully and has achieved good reductions. Capacitor achieved a 25% reduction against a value standard of 35%. The Canadian General Electric Company is achieving 55% reductions against a goal of 65% for the generator example we discussed earlier. A very successful medium transformer department team is now moving on to tackle other products in their line after a fine first effort. Incidentally, this case history is a good one, with which to spike the assumption that prime cost reductions as high as 30 to 40% are not possible unless existing design and manufacturing methods are weak and loose. Obviously, a poor design and poor manufacturing can be improved by any number of approaches. In this case, value control methods were used to wring out 40% of the material and labor costs of a good transformer, which was considered strong and tight because it had been cost reduced 45% during the previous 4 years. Summarizing, the heart of the method is the function structure. From it flow the three basic concepts of competitive analysis, minimum competitive composite, and value standard that brought to earth as solid numerical values are direct measures of the merit of our products. They show us where we stand in relation to competitors, to the best combination of competitors, and to the best that industry could produce today. So far, 22 teams have completed courses in value control. The training courses consist of 6 one-week sessions in Schenectady, spread over an 8-month period. Participating departments enroll a team of 3 men, a design engineer, a manufacturing engineer, and a product planner. The team uses a product of its own as a learning project, gaining an initial cost reduction. I began by saying that we believe that these value control principles and measurements are ready for general use within the company. While we readily admit that they are still being improved, we submit that they've already passed the test of leading directly to major product improvements, both in cost and in customer appeal. These measurements can be the planning base for sound product programs. They will enable you to set realistic goals for design or redesign. They lead to a product plan that combines the best of your competitors' products with the best of your own thinking in engineering, marketing, and manufacturing. I strongly urge, therefore, that you adopt this system of value control, its discipline, and its measurements as required business practice in your component. Thank you.